Hello, this week we're going to talk about quadratic functions. We'll start off right away with factoring quadratic expressions. First of all, what is a quadratic expression? It's any expression of this form here, where we've got coefficients a, b, and c in front of the quadratic, linear, and constant terms respectively, and a here, of course, has to be non-zero, otherwise it's not quadratic. Now, if we think about factoring, the opposite of factoring is expanding. So if we take a look at this expression on the left here, okay, and we expand it all out, we get this expression here on the right. Now, if we look very carefully at what happened in that process, we see that the a out front of the expression on the left was, of course, distributed in every term. And once we factor out the a from the linear term, we're left with p plus q. And what we're left with when we factor the a out of the constant term is p times q. So once we factor out a from every single term, then we're looking for two numbers that add up to give us the linear coefficient and multiply together to give us the constant. So we can use that as a method of factoring. It doesn't always work, but when it does, it's very fast. So our first step is to factor the quadratic coefficient. That's what a is here, out of every term. Now after that, we're going to try to, and this is through kind of guess and check. We're going to find two numbers that add up to the linear term and multiply to give us the constant term. Now, how does that help us? Well, what role are p and q playing in the original factorization? Take a look at them. Here they are here. They tell us exactly what the factors should be. Okay, we'll have x plus p times x plus q. So let's see an example of how this works. Let's say we take a look at the first one here. There's no quadratic coefficient other than, of course, the implied one, 1. So we don't need to factor anything out. We can go straight to asking ourselves, what are two numbers that multiply to give us plus 8 and add up to give us negative 6? If we think about that a bit, we end up with negative 4 and negative 2 as the two possibilities. Okay? Now, of course, if we wanted to, we could verify that what we have chosen is in fact correct. So if we multiply those two factors together, remember we're going to FOIL out here, so x times x times negative 4, negative 2 times x, negative 2 times negative 4, and we're going to get x squared minus 4x minus 2x plus 8, which of course simplifies to x squared minus 6x plus 8. Exactly what we needed to get. So we know we have the right factorization. Let's try another one, this time with a coefficient that isn't just 1. For instance, number 3 here, we notice there's a factor of 3 as our quadratic coefficient. We can factor it out of every single term. And then if we look at just what's in the brackets there, we'll again play the exact same game. What are two numbers that add up to give us plus 1 and multiply to give us negative 30? Well, if we think about that, positive 6 and negative 5 do the trick. So c plus 6 and c minus 5 are going to be our factors. And of course, we can check that out for ourselves, make sure that we've got the right answer, the right factorization. And again, we've got three factors here. We can do them whenever order we want. So maybe let's distribute the 3 into the first factor, both terms, of course. So we have 3c plus 18 times c minus 5. And then we FOIL that out. 3c squared minus 15c plus 18c minus 90. Okay, and we get exactly what we wanted. Now, factoring is an absolutely wonderful tool. The only problem is it doesn't always work. It's very fast when it does work, when you can quickly think of two numbers that'll add up to give you the linear coefficient and multiply to give you the constant. But sometimes it just can't work. Like in example 5 here, if I factor out the 2 from both terms, I'm left with j squared plus 7. And I'm trying to think of two numbers that multiply to give me 7 and add up to give me the linear coefficient. Well, there is no linear term, so the linear coefficient is 0. So I'm trying to think of two numbers that multiply to give 7. Let's write this down. And they add up to 0. Now, if you think about that for a moment, if we think of two numbers that multiply to give us 7, either they're both positive, or they're both negative. But then we have a problem. If we add up two positive numbers, we won't get 0. And if we add up two negative numbers, we won't get 0. So we can never have them add up to 0. Okay, so we're going to get here that there's no factorization. And sometimes figuring out the factorization is just too difficult. Okay, if we look at question number 6 there, can you figure out what a proper factorization should be? Now, if you give yourself about 20 seconds and you haven't figured it out, we're going to have to use another method. And we'll talk about other methods later this week. But please give the questions we didn't do a try here and fill them out for yourself. I'd like to move on at this time and talk about why we would use factorization. What is this useful for? Well, factoring is a very powerful tool. Again, it doesn't always work, but when it does, it can very quickly get us solutions to equations, actually. So if we have a polynomial and we can completely factor it, and that polynomial is equal to 0, like we have down here, then if you think about it, if we have the product of many things equaling 0, what can you say about that? Well, if the product of many things is 0, then one of those factors must be 0. And you can consider each possibility. In the first factor, x could equal this mystery number a1. If the second factor was 0, that would mean that x is equal to a2, and so on. Okay? So we can get our solutions very quickly that way. So for instance, if I have a factored expression and it's equal to 0 like in exercise 1 here, I can immediately think, well, if the product of three things is 0, that means one of the factors must be 0. If the first factor is 0, that means x is 5. If it's the second factor that's 0, that means x is negative 7. And if the third factor is 0, that means x is 0. We get exactly our three solutions very quickly. For our second example, we have really 4 factors here, but we've kind of got a double factor at the beginning. If x minus 4 is 0, that means x is 4. If x plus pi is 0, x is negative pi. And if x minus root 3 is 0, then x is equal to root 3. So factoring is an incredibly powerful tool. Just by being able to write one entire side of an equation as the product of many things and having the other side be 0, then we can look at each factor individually and ask, when is it going to be 0? We're taking a very complicated problem and making it much simpler. Now, in the case of quadratic equations, we can use this factoring technique to solve the quadratic equation. Like for our first example here, we can factor our left-hand side. What are two numbers that add up to give negative 5 and multiply to give positive 6? Well, negative 2 and negative 3 fit the bill. So now we've got a factorization of the left-hand side, but we're not done. Then we ask ourselves, when is x minus 2 equal to 0? Well, when x is 2. When is x minus 3 equal to 0? When x is equal to 3. So by this process, we can quickly find solutions to quadratic equations. So factoring can be incredibly quick when it works, but sometimes we can't figure out a way to make it work. Let's try another example here. How about we look at number 3? First of all, in order to use factoring, one of our sides has to be 0. So let's bring all our terms to one side. And now if I look at those two terms, I notice there's no constant term, so I could say the constant term is 0. So I'm trying to think of two numbers that multiply to give me 0 and add up to give negative 5. Well, 0 and negative 5 meet that criteria. So q plus 0 times q minus 5. Another way to look at this factorization is it's just common factoring. We notice that both terms on the left have a common factor of q. I can bring that out front, and the leftovers from the first term are going to be q, and from the second term will be negative 5. So now we've got our two solutions, q equals 0 and q equals 5. Now I'd like you to try out the rest of the examples here. If you have any difficulty whatsoever, please come and talk to me. Factoring is an incredibly important technique. And you can watch some later videos that will talk about other ways to solve quadratic equations. Thank you.